All right, let's talk about it. Schrödinger's cat. It's probably the most famous, and maybe the most misunderstood, idea in all of science, right? I mean, we've all heard about this bizarre quantum puzzle. And you know the question, it's so simple but it just completely messes with your head. Before you peek inside that box, what's the deal with the cat? Is it alive? Is it dead? Or is it somehow both at the same time? It's really become the poster child for quantum weirdness.
But what if I told you we've all been asking the wrong question? Seriously, what if that whole alive or dead thing completely misses the point? What if this whole experiment was never, ever meant to teach us anything?
Because here's the real story. Schrödinger's cat wasn't some friendly little metaphor to help us understand quantum mechanics. No way. It was a weapon for an intellectual war. Schrödinger was using this brilliant, ancient debate tactic. It's called reductio ad absurdum. Basically, you take your opponent's idea and you stretch it out to its most ridiculous, illogical conclusion to show everyone just how wrong it has to be. And the target he was aiming at? This brand new, radical theory of quantum physics.
So, to really get this, we've got to rewind the clock. We're going back to the 1930s, right into the middle of a huge, bitter fight that was tearing the world of physics apart. And look, this wasn't just some stuffy academic argument. This was a full-blown war for the soul of physics, a battle over what reality even is.
Okay, so you had two camps. In one corner, you've got the old guard, the realists. We're talking titans like Albert Einstein and Erwin Schrödinger. For them, reality was simple. A cat is a cat. It's either alive or it's dead, and that's a fact, whether you're looking at it or not. But in the other corner, oh boy, you had the new kids on the block, the Copenhagen School, with guys like Niels Bohr and Werner Heisenberg, and their idea was just wild. They said that until you actually measure something, it doesn't have a definite state. An atom, a particle, even a cat, it's all just a blur of possibilities. Reality, for them, only snaps into focus when we look.
And let me tell you, this was not a polite debate over tea. Einstein was absolutely livid. He called their whole approach an epistemology-soaked orgy. I mean, wow. Epistemology is the philosophy of knowledge. So what he was really saying is, you guys aren't doing physics anymore, you're just spouting philosophical garbage. The gloves were off.
You also have to remember the context. The year is 1935. The world is on fire. Fascism is on the rise in Europe, and both Einstein and Schrödinger are exiles. They've had to flee for their lives. So you can just imagine, in a world that felt like it was going completely insane, they looked at their own field, at physics, and saw this wave of uncertainty and randomness creeping in. It must have felt like the chaos of the world was infecting the very laws of the universe.
So the cat in the box, it didn't just appear out of thin air. It was actually forged, piece by piece, in a series of letters flying back and forth between Einstein and Schrödinger. They were basically co-designing the perfect intellectual bomb to drop on the Copenhagen Interpretation.
The whole thing really started with a paper Einstein wrote in 1935. He pointed out this incredibly weird thing the new theory predicted, that two particles could be linked, like magically connected, no matter how far apart they were. He called it spooky action at a distance. Well, Schrödinger read this, and a light bulb went off. He gave it the German name for Schrinkung, we call it entanglement, and he realized, this is it. This spooky connection is the weak point. It's the key to the whole attack.
And man, things escalated fast. In June of 35, Einstein starts off pretty tame, with an idea about a ball in a box. Simple enough. But by August, just a couple months later, he's moved on to something way more dramatic. A gunpowder keg that could be both exploded and not exploded. Then, get this, just 11 days later, Schrödinger takes that idea and sharpens it into the final, legendary weapon, the cat.
Einstein's whole point with the gunpowder was to show how silly this all was. He's like, are you seriously telling me a keg of gunpowder can exist in a blend of exploded and unexploded? It's absurd. In the real world, it's one or the other, period. There's no in between. But Schrödinger looked at that and thought, yeah, that's good, but I can make it even better. I can make it even more ridiculous.
So, let's look at what Schrödinger did. He took Einstein's idea and perfected it. And he had a name for his creation, a Holland machine. That's German for infernal machine. Think about that. He didn't see it as a clever puzzle. He saw it as something truly monstrous.
And this is where his cruel genius really shines. He swapped out the inanimate gunpowder for something alive, a cat. See, a keg of gunpowder that hasn't exploded is just a keg of gunpowder. No big deal. But a cat that is simultaneously alive and dead? That's just horrifying. It makes no sense. By doing that, he took this abstract physics problem and connected it to the one thing we all understand on a gut level, the absolute line between life and death.
And the device he imagined is diabolically clever. You have a single radioactive atom, just one. Its decay is a purely random quantum event. That atom is hooked up to a Geiger counter, which is hooked up to a hammer, which is poised to smash a vial of poison. So, the tiny, uncertain fate of one atom is directly linked, entangled, with the very large, very real fate of the cat. He built a perfect, horrifying bridge between the quantum world and our everyday world.
So Schrödinger's point was this: if you follow the Copenhagen rules, then until you look, the entire system is in this fuzzy, undecided state. The atom is both decayed and not decayed. The poison is both released and not released. And the cat is what he called mixed or smeared out in equal parts, living and dead. He even compared it to a shaky or out-of-focus photograph. And he was basically screaming, "This is ridiculous. Nature doesn't work like that."
So, the big question is, did it work? Did this infernal machine actually kill the theory? Well, no, not at all actually. What happened was, instead of giving up on the theory, physicists basically spent the next several decades trying to figure out how to escape the very box Schrödinger had so cleverly trapped them in.
And they came up with two main escape routes. The original Copenhagen idea is that, yeah, the smeared-out cat is real, and when you open the box, your observation forces reality to make a choice. It collapses the possibilities into just one. The cat is either alive or dead. But then came an even crazier idea, the many worlds interpretation. This one says there's no collapse at all. The moment that quantum event happens, the universe itself splits in two. In one universe, the cat lives and you're happy, and in a brand new parallel universe, the cat dies and you're sad. Both are equally real. Now today, the leading scientific idea is something called decoherence, and it's a really elegant solution. It basically says the whole paradox is a bit of a cheat, because the cat is never truly isolated. The observer isn't just you about to open the box. The universe is constantly observing. Every single air molecule bumping into the cat, every photon of light from the decaying atom, all of those tiny interactions are measurements. They force the cat into a definite state, alive or dead, almost instantly. The universe already knows the answer long before we do. Which brings us to the biggest, most beautiful irony in this whole story. Remember, Schrödinger designed this whole thing as a kill shot, a weapon to destroy a theory he despised. But what actually happened was something nobody could have predicted. See, for a long, long time, most physicists just ignored it. It was the whole shut up and calculate period. They had work to do, things to build. They didn't have time for philosophy. But then in the 70s, science fiction authors found the cat, and they absolutely loved how wonderfully weird it was. And then in the 80s, pop science books picked it up, and suddenly Schrödinger's cat was everywhere. It became the official logo for quantum weirdness.
So in a hilarious twist, Schrödinger's weapon totally backfired. His whole argument was, this is absurd, therefore it's wrong. But a whole new generation of physicists came along, looked at the absurdity and said, you're right, it is absurd. And that's what makes it so cool. The universe just is that weird. So the cat, instead of being the thing that killed the theory, ended up becoming its most famous mascot.
And maybe that's why, all these years later, we're still completely captivated by it. That cat isn't just in a box, it's sitting right on the fence between two different worlds. On one side, you have the fuzzy, probabilistic quantum realm, and on the other, our solid, classical, everyday reality. The cat in the box doesn't really give us any easy answers, but man, does it force us to ask the biggest, deepest questions there are.